Welcome back to Pre-Calculus. This video will cover Chapter 10, Section 8, Polar Graphs, day number 2. Now, I did mention these quick tests for symmetry in class as we went over today's lesson. If your graph is in this form, r is equal to some number times sine theta, you will have symmetry with respect to the line pi over 2, also known as the positive y-axis. So if we find a point here in quad 1, there'll be a symmetric point in quad 2. If we find a point here in maybe quad 4, we can jump across the y-axis and have a symmetric point in quadrant 3. On the other hand, if your function is in the term of some number times cos theta, your symmetry will be to the polar axis, also known as the x-axis. And then it says below, 2 additional aids to sketching graphs of polar equations involve knowing the theta values for which the absolute value of your distance from the origin is at a maximum, and knowing the angle values which will give you an output of 0. That's when you're going to come back and touch the origin. Blah, 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 blah. Let's check it out. So in our first example today, we're just going to do 2 of them. We're going to graph 1 minus 2 cos theta. Well, as soon as I see that cos theta in there, I know I'm going to have polar axis symmetry. And that's still kind of a new term to us. So again, x-axis. X-axis is the polar axis. Now, when it says the maximum value of this function, or the absolute value, I'm going to underline it in red. Remember, cosine can be a number between 1 and negative 1. So let's assume this cos is positive 1. Times 2 is 2. Let's assume this cos is a negative 1. So that negative 1 is going to hit this minus and make it into a plus. So we're going to have 1 plus 2. Our maximum r value is going to be 3. We should never see a number outside 3 and negative 3. And then it asks about the zeros. Well, if I set this equal to 0, and I want to solve for cos of theta, I would subtract 1 and divide by a negative 2. So that tells me that cos is equal to a half. And where is cosine equal to a half? At pi over 3 and 5 pi over 3. So those values should give us an output of 0. And right down here in the table, I don't see the 5/3 pi, but I do see the pi 3. We can plug in a 0 for that right now. Okay, so in class, we would use our TI-89 calculators. We would type this into the Y editor, and then we would type in the 0 and see our output is negative 1. At pi over 6, we'd get the decimal negative 0.73. That would be 1 minus root 3 if you were using the unit circle. At pi over 2, our output value is 1. At 2/3 pi, output is 2. And at 5/6 pi, it would be 1 plus root 3, or 2.7. And then at pi, our output is 3. And now remember, this isn't a lot of points, but we do have our polar symmetry, or x-axis symmetry. So let's hop over to this graph. I do have another table over here. I'm just going to put in my decimal for that and my decimal for that. Okay, let's plot some points. I'm going to switch to blue ink. At 0, we would go negative 1. So 0's over here. Negative 1 means we go through the origin. There's our first point. At pi 6, it's negative about 3/4. So at pi 6, we're going to go this way to about here. And we can, if we want, connect those dots. And the symmetry tells me this dot here. I'm going to go up and have another one up above. Maybe I'll do my symmetric dots in red ink. There we go. Up next, at pi 3, we're back at the origin. So at pi 3, here we are at the origin. That will be on the line of symmetry, so it's symmetric to itself. At pi over 2, we're going to go up here to positive 1. So it looks like we're going to come around here like this. And our symmetry says we're going to have a point down here. So we did this point. 2/3 pi, we're going to go positive 2, positive 1, positive 2. So our graph will continue like this. And we can do our symmetric point down here. At 5/6, we're going to go just short of 3. Here's 5/6. So we're going to go 1, 2, 2.7 would be about here. The symmetric point would be right down here below. And we'll continue our curve and connect up with that dot. Like that. And then at pi, we've got 3. 1, 2, 3 units. And then let's see here. We'll continue along. Go through the origin, through that point. There we go. So we've got kind of a circle here with a little loop inside of it. There we go, and we got by with what? 1, 2, 3, 4, 5, 6, 7 points, and knowing the symmetry of the graph. So here's one for you to try. It's 1 plus 2 sine theta. Let's go over kind of the new stuff together here. Because it has a sine theta, we're going to have y-axis symmetry. The most this can ever be, remember sine here is either 1 or -1. Let's say it's a positive 1 times this 2 plus 1. The maximum r value is 3. We should never see a number outside 3 or -3 on our table. And the zeros, I would set 1 plus 2 sine theta equal to 0, and then I'll get sine of theta is -1/2. So that's going to occur. Our zeros are at theta equals 7 pi over 6 and 11 pi over 6. So a good spot, stop the video, try the huddle problem, and see how it turned out after you get it done. Okay, first point here. Okay, I paused the video there. I noticed I did update the theta values in the table in your notes. So let's see here. 3/2 pi goes in. We get out a -1. 5 pi over 3 goes in. We get out about a -0.75. 11 pi over 6 goes in, and a 0 comes out. We predicted that over here. When 0 goes in, we get a 1 comes out. Pi over 6 has an output of 2. Pi over 3, about 2.75. And pi over 2, there's our maximum value, like we predicted here, 3 units. So let's plot some points. At 3/2 pi, that would be down here. I want to do -1. So that'll bring us up here as our starting dot. And remember, we do have y-axis symmetry. That is on the y-axis, so it won't have another point. At 5/3 pi, that would be going down this way, is -0.75, so right about here. The reflected point will be over here. Oops, nope, wrong ray. There it is. So I'm going to connect these in order. We started here, we come down to this one. At 11 pi over 6, we're at the origin. So we're at the origin now. At 0, we go out 1 unit. So here's 0, 1. And that means we will have a symmetric point. Right there. Okay, pi over 6, 2. So here's pi 6, 1, 2 units out. The symmetric point will be straight across the y-axis. There we go. Pi over 3, 2 3/4. So here's 1, 2, and 3/4 will take us to about here. If I look straight across, there's our symmetric point. And at pi over 2, we go up 1, 2, 3 units. So I'm going to connect those in the order I graphed them. I already have the first 2, and then we're going to loop around this way. And then come up, come around, down, go through the origin, through that last blue point, and then right up there. So again, we got kind of a circle shape, but then there's a little twist that comes in right there at the origin. I hope your graph turned out as good as mine. Example 4, sketch another polar graph. Again, this will be our last one for the day. So, symmetry. We've got a cosine wave. Oops. So cos wave tells me it's going to be x-axis or polar axis. Oop, and I guess I should have had that down here for symmetry. The max value of our distance from the origin, well, cos is always between 1 and -1. If it's a positive 1 times this 2, our maximum value should be 2. Now the zeros, if I set 2 cos of 3 theta equal to 0, I could divide this 2 out. 0 divided by 2 is 0. And then I'd ask myself, where is cos equal to 0? Well, cos is equal to 0 at cos is equal to 0 at pi over 2, 3 pi over 2. And let's go one more, half trip around, 5 pi over 2. Now, if I divide each side by 3 or multiply by a third, I would get pi over 6. 3 pi over 6, that's going to reduce down to a half pi. And then I would have 5 pi over 6 as my zeros. So let's see, zeros. Here's pi 6 and pi over 2. Well, here's pi over 6. That's a 0. Pi over 2, way over here on the end of our table, that's also a 0. Now, if we put this in our calculator in the y editor, when 0 goes in, we should get out a 2. Pi over 12 is not on the unit circle, but when we multiply by 3, it'll be 3 pi over 12, or pi over 4, and that gives us a value of root 2, or about 1.41. Pi over 4 gives us a negative root 2, or a negative 1.41. Pi over 3 has an output of negative 2. We already said our max value was 2, and well, here it is at 0, 2, and pi thirds negative 2. So we predicted those. And then 5 pi over 12 gives us a negative 1.41. Okay, let's plot some of these points. Let me get my decimals in here. 1.41, negative 1.41, negative 1.41. So 0, 2, we're on the 0 radian axis. We're going to go out 1, 2 units. And then the next one is pi over 12, and that would be in between. If this is pi over 6, pi over 12 would be halfway down, and we're going to go out almost 1.5, 1.41. There we go. At pi 6, we're at the origin. So, this part we could sort of graph like this. There we go. Pi over 4 would be here in the middle. Pi over 4. The negative shoots us across the origin, so we're going to go to about here. And actually, let me connect the dots at the ends. Let me throw this away. There we go. Pi over 3, negative 2. Here's pi 3. Negative 2 sends us across here. Negative 1, negative 2. 5 pi over 12, if this is pi over 2, this would be 6 pi over 12. So 5 pi over 12 is right about in the middle here. And we're going to go negative 1.41, so right there. And then pi over 2, we're back at the origin. Now if I back up, remember we have x-axis symmetry. So any of these red dots will have a symmetric point straight across the x-axis. So this dot here will have one here, and it looks like over here is kind of like we have a little loop coming out, like so. Now this point right here, I'm going to go straight up, symmetric across the x-axis, and then we'll have another point here and here. So here looks like a second petal on our flower, and then finally here is our third petal on the flower. Notice here at pi 6, actually I have this little loop. This at pi 6, we should have never touched that line. It's kind of like an asymptote. And also at pi 2 would also be like an asymptote. So there's kind of our 3-petaled flower. Last thing in the video here, give this one a try. Plug it into your calculator. This is going to have y-axis symmetry because it's a sine wave. And we can figure out our zeros and our max values. Again, pause the video and give this one a try. Okay, so 0 goes in, 0 comes out. Pi over 12 goes in, 1.4 comes out. Pi 6 has an output of 2. Pi over 4, the 1.4 again. At pi over 3, we get a 0. 5 pi over 12 is negative 1.4. And pi over 2 is negative 2. So at 0, we are at the origin, first dot. Pi over 12, again, if this is pi 6, pi over 12 is halfway down, about 1.5. So right here, at pi 6, we're out 2 units. At pi 4, which would be right about here in the middle, pi over 4, again, 1.41. And then at pi 3, we're back to 0. 5 pi over 12, again, this would be 6 pi over 12 is a half pi. So we're looking at right about here in the middle. That's negative 1.4, so that's going to send us across the origin about to here. And then pi over 2 at negative 2. Pi 2 is straight up, so negative 2, we're down here. And again, this is a sine wave, so we have y-axis symmetry. This point right here will reflect across the y-axis. There's our symmetric point. This one at pi 6 will be the same at 5 pi 6. And then we'll have a dot here and here when these are reflected straight across the y-axis. So once again, it looks like a 3-petaled flower. We're going to come out here and have our first petal. And then we're going to come down into the quadrant 4 and 3. There's another flower petal. And then up in quadrant 2, there's our last one. All right. I hope yours worked out. We will have a worksheet for this. There's just going to be 2 problems, one on the front, one on the back. See you in class.